Hi everyone, we will discuss a problem today called level order traversal of a binary tree. So let's look at some examples and the problem statement here. So given a binary tree, we will need to return an array to represent a level by level traversal. So we need to populate the values of all nodes of each level from left to right in separate subarrays. So let's look at the example. We have a binary tree here. So basically we would need to return an array with 3 internal subarrays, and each subarray would represent a level in this binary tree. So we can see the first subarray has 1, second has 2 and 3. That corresponds to the nodes 2 and 3 here. And the third subarray has 4, 5, 6, 7 corresponds to the nodes 4, 5, 6, 7 here. A very similar example here. So we are given 12, 7, 1 and then 9, 10, 5. So we would need to return an array with 3 subarrays, and the subarrays would have to be 12, 7, 1 and then 9, 10, 5. Alright, so this problem, it obviously falls under the binary tree category. It also falls under the breadth first search, and because that's the technique we'll be using to solve this problem. So let's think about how we can use the breadth first search here. So we'd have to use a queue. So generally for BFS problems you have to use a queue. That is very important to remember. We have to use a queue when we use the BFS technique. So the algorithm will be something like this. So we'll use the queue, and in the queue we will first add the root node. So if we look at the second example here, we'll first add 12. Then for every item in the queue, we'll basically iterate through the items, and we will add in an internal array the value of that node. So we'll add 12. So now we have 12 in the queue. So we now extract 12 from the queue. We add 12 to an internal subarray. That's the first internal subarray. Then we add the children of 12. We add 7 and 1 to the queue. So actually, instead of just me talking about it, let's look at some diagrams to really understand what this is, and then we'll come back to the algorithm here. So here we have 12, 7, 1, 9, 10, 5. So we first add 12 to the queue. That's what we're doing here. We're adding 12 to the queue, and then we have the queue size is 1. So then what we do is we take that 12 and we add it to an internal subarray. So this is our first level. Okay, so for queue size 1, for one item we add that 12 to our internal subarray, and then into the queue we add the children of 12, which is 7 and 1. We add that here. Okay, in the next step, for each item in the queue, because now in the previous step we added 7 and 1, so now our queue size is 2. So for each item in the queue, we're going to add the children of those items. So for 7 we end up adding 9, and then for 1 we end up adding 10 and 5. There we go. And we also add 7 and 1 to another internal subarray, and we concatenate that internal subarray to a result array. So we have 12, the first internal subarray, and then we have 7 and 1, the second internal subarray. Meanwhile, our queue would contain 9, 10 and 5, as we can see here. So as before, what we do now is we add 9, 10 and 5 to a third internal subarray, and we will add that third internal subarray to our final result. And obviously 9, 10 and 5 have no children, so that's the answer. So let's go back and look at the text here. Basically what we do, we start by pushing the root node to the queue. We start by pushing 12 to the queue. and then we have to use a while loop, and we keep iterating until the queue is empty, right? So, and then for each iteration we count how many items are there in the queue. We'll call it queue size. So we'll have as many nodes at that level, and for each of the items in the queue, which is equal to queue size here, we push their value into that internal subarray. Let's call the current level, and then once we do that, we remove each node from the queue, and then insert both of its children in the queue. And this, we just keep doing that over and over again until the queue is empty. All right, so let's write some code here. So I have some classes, some Java code plugged in here. So I have a tree node right, okay, here we go. So I have a tree node. Let's go back and, all right, I have a tree node class here. So this basically represents each node in the binary tree, and then I have this from array helper. It's just so I don't have to, you know, keep doing a root dot left dot left dot left dot right and so forth. It's just easier to construct the tree this way. So basically it just represents the second example we looked at earlier. So we have 12 children, 7 1, 7 as a child, 9, 7 has no right child node, so we put a -1 here, and then we have 10 and 5, the children of 1. Okay, so here's we have, and then we just use that from array helper function to construct the tree. All right, and then basically we have this function here, traverse function, which should return the array with the nested subarrays inside it. So we construct this result variable that we're going to return here. So now we have to write some code for the algorithm we just discussed. All right. So as I mentioned, we have to use a queue. The queue of, we have to use the queue of the tree node. We'll use a linked list here. So let's just initialize this guy first. And then remember, we're going to add the root to the queue. And then the algorithms, as it says, we have to keep iterating until the queue is empty. So we'll use a while loop here. So keep iterating while the queue is not empty. I think I said the reverse earlier, but we have to keep iterating while the queue is not empty. Now, I mean, generally it's a good idea to disable IntelliSense just for practice. So this, by the way, I'm using VS Code here. It's pretty convenient, but when you're practicing, it's a good idea to disable IntelliSense. I'm probably going to do that from the next video. All right. So now we have to use this queue size queue. So I really wasn't sure if it was dot size or dot length, so IntelliSense came in handy here, but yeah, definitely practice by disabling IntelliSense. I forgot to do that before recording the video, but just remember that. Alright, now we have to use a we have to use an internal array. So so let's call that current level. And now we have to for each item in the queue. So basically, so for each item in the queue, which is the number of items is this queue size is equal to queue size, we have to get it from the queue and then add the value to this current level list, and then we have to check if it has children. If it does, we have to add the children to the to this queue here. Okay, so let's do that. Equals 0. I less than queue size. So we get that item from the queue, and then we're going to add it to current level here, and then we check current node dot left is not null, then queue dot offer node dot left, and then right is not null. Okay, and then finally, we have to add this guy to the final result. We have to do that inside the while loop. So and then we finally return it. Okay, that should be it. So let's run it and see what we get. Right, and we got 12, 7, 1, and then 19, 5. Okay. So time complexity for this algorithm is O of n, and where n is the total number of nodes, because clearly we're walking through all the nodes here, and space complexity is also O of n here. Alright, that's it. Thanks for watching. Bye.